part, we're going to find area and circumference of circles or half circles, and then we'll get into composite figures. So for the first circle, we're going to find the area. To find the area, I need to know the formula, so let's check that out. The formula is A equals pi r squared, where r is the radius. And pi is just a number. We'll talk about that in just a second. So area equals pi r squared. So for pi, we're just going to use the number 3.14 because if we use the pi button, it's going to actually give us a really long, crazy decimal. And on your SOL test, it'll actually just say use 3.14. So we're always going to use 3.14 for pi. And the radius is, in this case, it's 4. So 3.14 times 4 squared. Okay, we can take that and put it in our Desmos calculator. 3.14 times 4 squared, and we get 50.24. So area equals 50.24. As always, we need to include our units. So since we're talking about area, it's going to be square units. And it didn't give us the name, but that little dash signifies feet. So it is 50.24 square feet. Circumference is a different formula, so let's check it out. So circumference you can find two ways. You can find it as 2 pi r if you have the radius, or you can find it as pi times d, which is diameter, if you have the diameter, which is all the way across the circle. In our case, we're going to use 2 pi r since we know the radius. So circumference equals 2 times pi times r. And let's plug in what we know. Remember, we always use 3.14 for pi. So 3.14, and I can't forget the 2 in the front. It's 2 times pi times r, and r in this case is 4. Take that, plug it in, see what we get. 25.12. So our circumference is equal to 25.12. Always include the units. In this case, it's feet. Now for this one, we're going to start off in a similar way, but this looks very different. This is actually only half a circle. So to find half of the area, I need to do half of the area formula. So instead of just being pi r squared, I'm going to write it as 1/2 times pi r squared. Area equals 76.93. In this case, it is centimeters squared. So sometimes we see that written as centimeters with a little squared, or you could just see it written as squared. Circumference. So if this is kind of tricky because if I wanted to know half of the circumference, I wanted to know like the perimeter of this shape. The shape is actually half of the circumference and then this bottom part here. So we'd have to find half of the circumference and then also add this bottom part. So if the circumference is 2 pi r, well, half of that, or 1/2 times 2 pi r, really just kind of cancels out. What 1/2 times 2 is just 1. So we're really just going to get rid of the 2 right here. So the circumference is pi times r, and then we're going to have to add this bottom part right here. So maybe let's say like the base. And let's figure it out. So the circumference is 3.14 times the radius, which is 7. And I'm not even going to call this circumference because this is actually just the perimeter of this half, this semicircle. And then remember, we have to include that base. Well, how long is this base? It's the diameter of the circle. If half of the diameter is the radius 7, there's 2 7s. There's 7 here, for a total of 14. We get an answer of 35.98. So we'll say that the perimeter of this figure is 35.98 centimeters. All right, big thing is composite figures. Composite figures, they are shapes that are constructed from two or more shapes. So it might be a triangle and a rectangle, or a trapezoid and a semicircle, or something like that. The area can be found by breaking up the figure into smaller shapes that you recognize, and then adding or subtracting those based on the figure itself. And there's not just one right way to do it. So you really just have to think about, if I have a composite figure, a figure that's made up of multiple shapes, what shapes are inside of it? How would I find the area of those figures? And then add those together. In some cases, you'd subtract them. And the perimeter still just holds true for perimeter in general. The perimeter of anything is the distance around the outside of the figure. So you can find perimeter just by adding up the outsides of the figure. There's no one formula for it. So we'll do an example together. Here is our composite shape, and we're going to find the area of it. There's no just regular formula to plug in. We have to break this down into smaller shapes. So let's talk about it here. What shapes do you notice in this figure? So by that I mean, do you notice a triangle? Do you notice a rectangle, a circle? What do you see? Well, when I look at it, I see two triangles. This is how I see it. And you might see it differently, and that's totally fine. I see a rectangle up top and a rectangle on the bottom. That's one way to see it. You might see it differently. You might see it as a triangle on, or I'm sorry, a rectangle on the left and a rectangle on the right. Okay? Either way works. Let's actually do it this way. Okay? So let's divide this up into a rectangle on the left and a rectangle on the right. And I'm going to call this figure A and figure B. We got figure A and figure B. So in order to find the area of this whole figure, we have to think, well, not only do I see a rectangle A and a rectangle B, but what formulas would I use to find the area of those shapes? Well, what formulas would you use to find the area of any rectangle? Think about the formulas we've been using before. Find the area of any rectangle, we use the formula area equals length times width. So that's what we're going to use to figure out the area of this composite figure, okay? So here we go. So we've broken this down into figure A and figure B. Let's start by finding the area of figure A, which is a rectangle. We've actually said figure A is a rectangle and figure B is a rectangle. And to find the area of a rectangle, we use the formula area equals length times width. So let's take a look at figure A. Figure A is right here. What is the length and width of this rectangle? I see a lot of different measurements. 8 inches, 9 inches, 11 inches, 4 inches. So if we're just looking at figure A, which actually pertains to the length and width of just figure A? Well, I'm going to draw a little shape on top of this to kind of see it a little bit easier. So if this is figure A right here, what is actually measuring the length and the width? It's actually going to be a length and width of 9 and 8. So we'll say that the area equals 9 times 8. Hopefully we can do that in our heads. If not, use your calculator. We'll find that the area of figure A is 72 square inches. Because this little symbol means inches, 72 square inches. Remember, this is just the area of figure A. Okay, and let's actually add that to our picture so that we can kind of keep organized a little bit. Area A is 72 square inches. All right, so area of A is 72 square inches. Now we're going to find the area of figure B. So B is also a rectangle, but we're definitely not going to use 9 and 8 because it's going to be a little bit different. Let's find the area of figure B. I'm also going to draw a little rectangle over B. If I were doing this on a piece of paper, I'd probably have like some colored pencils or something so that I could see what this little rectangle looks like. So 4 is talking about the length of it, but what's the width of this? 11 is referring to the length all the way from here to here. So 11 is not quite the length of it. We really just want to know what's the length of this little piece right here on the bottom. Well, if this whole length is 11, and we know that this much of it is 9, so that much of it is 9, the whole length is 11, how much would be left over to get from 9 to 11? So we could think about it maybe by subtracting 11 minus 9, or we might just be able to think of what do I need to add to 9 to get to 11? And we'll find that we have a remaining 2 inches for this little part right here, because 9 plus 2 would get us to a total width of 11. So the dimensions of of rectangle B right here are actually 2 by 4. So that's what we're going to use. So while we're still going to use the same area formula, area equals length times width, we're going to say that our length is 2 and our width is 4. Or you could switch those around. The area is 8 square inches. Okay, so we found area of figure A, area of figure B. The area of the whole figure is just those 2 areas added together. So we're going to add area of figure A plus area of figure B. So we have 72 plus 8 for a total of 80 square inches. So that's going to be the area of the entire figure. And if you want to see it just in the figure itself, let's do this. So remember, the area of figure B we found was actually just 8 square inches. So together, 72 plus 8 give us a total of 80 square inches. So we talked about the formulas we used. In this case, they were both rectangles, so we used the rectangle area formula both times. That's not always going to be the case. Sometimes you're going to use, if you have a triangle or something like that. In here, some other ways to explain this. No matter how you break up the figure, this is how we broke it up. You might break it up a different way. We're always going to get the same answer of 80 square inches. The last thing we're going to do is we're going to find the perimeter of the figure. Remember, there's no formula for finding the perimeter of a composite figure. You have to think about what perimeter is. It's the distance around the figure. So let's take a look. And we're going to use the same technique that we did for rectangles, triangles, trapezoids. We're going to kind of trace around the figure and figure out what all the lengths of the different sides are. So let's start here. So this side is 8 inches. Try that again. And make that a different color so it's easier to see. Okay. Then we have this side right here, which is 9 inches. How about this side right here? They don't tell us how much that side actually measures. So we need to figure that out. Well, how could we figure that out? Let's look at what else we know. I'm going to actually make that a different color because it's something that we're going to have to look for. We're also looking for this side length. We know that this next one is 4. Because they've told us that, so that's good. And then we know that this side is 11. Okay, so we're looking for these 2 missing blue sides. You guys actually already figured out that this side right here, this little short side, is 2, because we said that 11 minus 9 gives us a remaining 2. So if this is 9 inches, I need to go 2 more inches to get to a total of 11 inches. Okay, so we used 11 and 9 to figure out that that one right there is 2. We can do a similar method to figure out this missing side. So if the total height of the figure is 8 inches, the bottom part of it is 4 inches, and we need to know, well, how many more inches do I need to go to get to 8? So you can do it a couple ways. You can think about it as 8 minus 4. That gives you 4. Or just think, what do I need to add to 4 to get to 8? We're just actually going to add another 4. It's not always going to be the same number like that, but in this case, that's how it worked. So we have 1, 2, 3, 4, 5, 6 different sides that we're going to add up, and we have 1, 2, 3, 4, 5, 6 different numbers. So we're just going to add up those numbers to find the perimeter of our entire figure. So the perimeter of this figure is going to be 38 inches. So those are how you find area and perimeter of composite figures. Even though the figures are going to look different each time, you're still going to apply the same concept. So perimeter, just add up all of the outside edges. You might have to find some missing pieces. For area, subdivide it into smaller figures and then add those figures together. There are a few exceptions where you might have to subtract if a figure was taken out of another figure, but really it's all going to come back to these basic shapes right up here on your formula sheet, and use those formulas.